don't think it's as hard as some people make it out to be, because half of it is done by salt. And you know, when salt takes over, all you need to know is where to put the numbers and where to read the answer, right? So as long as you do a couple of them, hopefully that'll become pretty good. So that's what's going to happen next week. The Monday after that is going to be our third and final test. That's cool. And that's the week that Thanksgiving on. So this is the change in plans. Tuesday will not be a class day. What will happen on Tuesday is that you'll get ready for Thanksgiving or drive to your Aunt Jessie, whatever you do. And I will make a video on Tuesday that you will watch when you have time. And the Tuesday video will essentially be what we would have covered if you had been in class on Tuesday, right? So it's not that we're going to miss the work. I'm just making it a little bit easier because I know that Thanksgiving is a big thing in America and a lot of you have things to do and it gets in the way. Wednesday, Thursday, and Friday, we're always going to be off. So that basically is the end of that week. Test on the Monday. Watch a video whenever you want on Tuesday. And then when you come back from Thanksgiving, we have one last week to finish off the course. And then it's the final. Aye. Time's flew by, hasn't it? Yeah. But hey, can you see the end of the tunnel? We're almost there. Try and do the best you can in this test because you know the best two count. So if you had a real stinker of a test, this is your chance to throw that one away and get a better one in its place. If you've got two really good tests, then it won't really matter much, right? It won't affect your grade because that'll be the one that'll throw away, right? So it can't hurt your grade. It can only help your grade, right? Third test. So let's get started. Let me close some windows and open some others. Here we go. Darn it in space. Excuse me. I got a window in the way. How do I make it go away? Okay, I'm fighting a window here. Do that. Is that going to help? Yes, sort of. Close that one off. If I do that, so I'll be here for the next 20 minutes there. That's the best I can do. Right, so we're going to estimate the difference in two means. And in particular, we're going to do essentially some homework questions. And to remind you, we're really interested in finding confidence intervals for the difference between two means. And that's the generic formula. But we don't need to do this formula anymore because today it's all about letting salt do that formula. And the typical ones are 95%, but you can also do 90% and you can do 99. They're the three most common. And when we do that interval, one of three things is likely to happen. And when that does, we can interpret something. So for instance, let's suppose we were measuring the height of Scottish people, that was population 1, and let's say French people is population 2, and we were measuring the heights. And so what we're really doing is estimating the difference between the heights. And you could get an answer, 5.1 to 6.2. You might get an answer, negative 1.3 to negative 0.2, or you might get an answer like negative 5.1 and positive 3.7. So let's say it's a 95% confidence interval, that the difference between Scots and French is a positive number. Wouldn't that mean that Scots people are taller than French people? Because all the numbers are positive. In fact, if I was being really precise, couldn't I say not only are Scottish people taller than French, they're probably 5 inches or more taller. Now, if they are negative numbers, isn't that the opposite? Scotsmen are smaller than French. And if you get one either side, and you'll see that they tend to use for a phrase like contains zero. That's not enough evidence to show that they're different. Are we all comfortable about that quick kind of summary of what we did? Are we good? Right, let me close that off now and open a different window, which is the homework window. And I'm going to see if I can do that shared screen thing, because I think it's distracting when I'm opening and closing windows all over the place. It's hard to keep track of where I am. Right. You should be looking at a double window. Is that correct? Two different windows? No? Yeah, okay. Now, here are the questions. Here is salt when we need to do it. Hopefully we can do that. Where shall I go? And let's start at the bottom. That way if I run out of time, I know I've covered the hard ones. So this is question 12. Volunteers who have developed a cold within 24 hours were randomized to take either zinc or a placebo. Okay, so it's one of those tests, which is a common theme with many of these questions. 29 of them were in the zinc group, and 25 took the placebo. And for the zinc people, it was an average of 4.4 days before they recovered from the cold. And the standard deviation for that group was 1.5. And then for the placebo group, it took them longer. It took them 5.8 days to recover from their cold, and their standard deviation was 1.9. So basically, you've got two distinct populations which have collected a sample from each. One of them took zinc, 4.4 days to recover, and there were 29 in that group. And then the ones that got a placebo took 5.9 days. And so we are going to look for a 95% confidence interval for the difference in the means. So you hit salt and you make sure that you're in inferential statistics, and you make sure that you click on the two sample, right? And now it's just a matter of making sure that you do whoever's going first and whoever's going second. And that is placebo first, take away the zinc people second. So placebo first. The mean for the placebo was 5.8 days to recover. The standard deviation for the placebo people was 1.9. And the sample size was 25. Now, in some of the other questions, not in this one, but I've seen it in some of the others, they mention things about degrees of freedom and standard and conservative degrees of freedom and all sorts of things. And you might think, how am I going to use those numbers? Or even should I use those numbers? Actually, you don't need to. SALT takes care of it all. All you need is sample size, mean, and standard deviation for the first group, and the same three things for the second group. Any other information that they give you is not necessary to answer the question. Now, if we look at the second group, which are the zinc people, it's a 4.4. So they took a little bit less time. And the standard deviation was 1.5. And in that sample, there were 29 students, 29 people. Are we comfortable about how you do a two sample and where population one sample goes and where population two samples go, right? And you want a confidence interval, and it's a 95. So you make sure it's 95. Now, there's a funny box here that I've never talked about. So let me talk about it right now. Some of these stories, not this one, but some of these stories might say that the data is pooled. P-O-O-L-E-D, right? Have you seen a question like that in the homework, Robert? I can't hear you. Hit spacebar. Oh, he's on the phone, right? Thought he was talking to me. So what you're going to have to do there is, if they mentioned it's pooled, hit that box. If they don't mention it, and it says here, leave unchecked if you're unsure. So if you're unsure or they don't mention it, just leave it alone and then generate the results. Can you see that the lower limit now is this number and the upper limit is that number? That's your interval that you want. So I'm just going to copy that guy, drop it into box 1. Copy the upper limit eventually. Upper limit, drop it into box 2, and then read the question. And the question says 2 decimal places. So, and 348 becomes 35. That's the end of that question. It was more button pressing than typing, wasn't it? I wish they had a part B to this. They do in some. Would you agree that that's evidence that the people who take the placebo have longer time to recover than the zinc? Isn't the first guy bigger than the second? So the people who just got a placebo pill take somewhere between what, a half a day to 2 days longer to recover from the cold. Right. So if everything else is correct, isn't that evidence that zinc helps reduce the longevity of catching the cold? So it may not stop you getting the cold, but if you do get the cold, it probably won't last as long. Which probably explains, isn't there a lot of zinc supplements floating around, especially at this time of year, if you go into pharmacies and so on? So my inclination is that there's probably some truth in that. You know, taking zinc, even if it doesn't stop you getting the cold, at least will make it a milder cold. Okay, here's our next story, kind of working backwards, but yeah, that's fine. The students answered questions about alcohol use and hangovers. Not that any of you have either of those things, right, Christy? Agreed. Lauren? No, ain't happening, don't know what you're talking about. Good. So the students answered truthful questions, we'll assume, about alcohol use and hangovers, including a count of how many out of a list of 13 possible hangover symptoms they experienced in the past year. Wow. So I guess there's a big list like dehydrated, headache, dizziness, who knows what else, feeling nauseous, right? All the things that could happen. And the answer that they got was as follows. 470 men. So that sample has 470 in it. The mean number of symptoms was 5.5. And for 755 women, so the second group's going to be self-identified women, and that's going to be 735, and the mean is 5.3. Standard deviation for the women is 3.6. And I guess I'm going to have to go up to the top there. What's the standard deviation for the men? 5.5. No, that's not right. Oh, for each of them was 3.6. Okay. So both had the same standard deviation, right? So that's just got the story. Men and women, 470 men, 755 women. How many of these symptoms have you get when you get a hangover? And the men, it was about 5.5 of those, and women, it was 5.3, and the standard deviation was 3.6. So the parameter of interest here is the difference in the mean number of hangover symptoms. Would you agree that's typically what we do? Move on. Oh, that's it. Find the standard error of the difference in means and round the answer to 4 decimal places. Now, I could do that on paper, couldn't I? Because we know the formula for it. But wouldn't it be nice if we could just let Salt do it? Great. So, if we go over here to the right-hand side, I guess I'll have to decide who's first and who's second. I'm assuming that since there's nothing else that men are first and women are second, so here goes. For the men, the number was 5.5 and the standard deviation was 3.6. And there were in the sample 470 men. And then for the women, it was a little bit less, 5.3. And standard deviation was also 3.6. Do you think that there's a big enough difference between these two for the interval to come out to be always positive? Because they are quite close, aren't they? 5.5 and 5.3. Right, there's not a heck of a lot of difference. So let's find out. Now, in this case, the second sample 5 was 755. So, right. There's no mention of it being pulled, so I'm assuming that doesn't matter, and I'll just generate results. And guess what? On this side, we got that number, and on the upper bound, got that number. And the standard error, can you see it? It's right there, and don't even need to calculate it. And then I read the question, and they want 4 decimal places. So, okay, if you want 4, that's your answer. And this other one wants 2 decimal places. So the 215 becomes 22, and the 615 becomes 62. Are you comfortable about how Salt really takes a lot of the stress off these questions once you figure out what the heck goes where? Okay, they finish with a little question. On the basis of C, do you think that there is a difference between the two? Would you agree that contains 0? So may or may not be, I guess, is from the choices. Would you agree that's all we can say? We don't know. There may or there may not be a difference. Now, if they gave me a choice that says there's not enough evidence to show there's a difference, I probably would have chosen that sentence, but I think in English isn't that the same thing. So we are good. Any questions about that one? It's working backwards. Moving to our next one. Who thinks these things out? This is silly, but do you know, it's not as silly as reality. Do you know the government fund research into the dumbest things? They literally spend millions of dollars measuring things that nobody in their right mind has any vague interest in. So it wouldn't surprise me if some university guy got a grant to do this. A sample of 34 men had a mean head circumference of 57.4. So men, there was 34 in the sample, and their mean was 57.5. And the standard deviation was 3. And then we went on to women, and there was 4 women, and it's 54.9, and the standard deviation for the women was 1.4. Somebody in a pub had an argument, and it went something like this. Men are big-headed. No, they're not. Yes, they are. Okay, I'm away to get a government grant to prove it to you. God, you'd be amazed at what you can get money to search for. And so you got a couple of $100 or whatever, I don't give me a big grant to do this. Would you agree that 57 is bigger than 54? So do men have big heads? Probably, physically big heads. But is that evidence, right? Because we don't know yet because we haven't done the confidence interval part. Now it says, find the difference between the sample means for men and women and round off your answer to the nearest 10, right? That goes there. Find the standard error, that goes there. And find the 95% confidence interval, that goes there. I'm going to let Sol do all of that because it is there. So I'm going to go over here. And the men, I believe, are going to go first. So they're going to be 57.5. The standard deviation for the men was 3. And there were 34 of them in that sample. And for the second lot, the women, they were a little bit smaller heads, 54.9. Ooh, that's a big head. There we go, 54.9. They're the much smaller standard deviation. And the sample was 34 as well. There's no mention here about pooled or unpooled, so I'm just going to generate the results. And let's see, the mean difference is 2.6. The standard error is that guy there. And to the nearest 10th, that's 0.6. And we have the range in the 95 is anywhere between 3.7 and a bit. No, that's the upper limit, sorry. Anywhere from 1.4 and a bit to 3.7 and a bit. So what do they want? Oh, they want the nearest 10. So that becomes 1.5 and this becomes 3.7. Okay, is there enough evidence to prove that men are big-headed? Look at that interval. Is there enough evidence to prove men's heads are bigger than women's? Yeah, based on that very small sample. So now you can go to a pub and you can say, nope, it's not a matter of opinion, it's a matter of fact, because I got money and I did a statistical survey on it, and I got evidence at the 95% level. Are we feeling a little bit more comfortable about this process now that you've seen 3 of them, that they have a kind of flow to them? Right, let's move on to the next story. I wish they had more imagination. How many cold stories have we had so far? Tons, right? Seems to be the only thing they have a story for. Okay, volunteers who have developed a cold. So it's another one of those. And they had to take either zinc or a placebo. So I guess zinc is one of the groups, placebo is the next. %. Am I getting deja vu? Oh no, it is different. It is slightly different. I need to keep going. I was going to say, have I not done this exact same question? Maybe with different numbers. It's very similar to one that we've done. So 25 took zinc. So sample size is 25. 23 took the other, the placebo. Done. For the placebo group, 7.3 days. Obviously a different sample. And their standard deviation was 1.4. For the other group, 4.3 days. And their standard deviation was 1.4. Right, they want us to get the difference, standard error, and they called it unpooled. Fair enough. But since we've been using unpooled all the time, I don't think that's particularly interesting. If they had said pooled, I'll do that in a minute. Right. So let's put all the data in. We just want to make sure who's first and who's second. Yeah. Did I mention who's first and who's second?
Judging by the numbers, placebo's first and zinc is second.
Sounds like a plan. Let's do it that way then. So first group is placebo. So that's going to be 7.3 again. Standard deviation for the placebo group is 1.4. And the sample size for the placebo was 23, quite a small group. If we do it in the second sample then, which is the zinc, their average was 4.3. And their standard deviation was also 1.4. And this sample size for the zinc group was 25. Since they said it was unpooled, leave that box unchecked. So if they don't mention it, use the, leave it unchecked. If they say it's unpooled, still leave it unchecked. If they ever say pooled, which so far I haven't found one, but if they ever do say it, well, you click that. That's the only difference you'll do. Right, so if they say the data was pooled, something like that, check that box. Now, let's hit the confidence, generate the thing, and let's get the answers. The difference is 3, check. The standard error is this number. Check. The lower limit is from 2 and a bit. And the upper limit is 3 and a bit. Now I'll go back and round off. Round off to 4 decimal places. So 1, 2, 3, that 4, 4 becomes 4, 5. Round off to 2 decimal places. So that's 2, 1, 9, and that's 381. Okay. We want to see what pulling the data does, how it changes things. So let's try it. Generate results. Do you see this number and that number ended up being to 2 decimal places exactly the same? In fact, as far as I can see, there was no difference. But I think that happened because weren't the 2 standard deviations the same?
The degrees of freedom changed.
Oh, the degrees of freedom changed. Oh, because of the n minus there. Okay, so the only obvious thing is degrees of freedom. Right. So do you know, it looks to me like as long as the data's not too big, even if you don't check it, won't you probably get the same numbers? The difference in the standard error. If you're wondering what the pooled and unpooled is about, if you have 2 populations that are very similar to each other, maybe the only difference is their means, but you know that their standard deviation are the same, right, or approximately the same, then you can pull the data and basically you can calculate the standard error in a slightly different way, where what you do is you put all the data together as if it was a single bunch of data and find the standard deviation of that divided by the square root of the n. The chances are that it's not going to make a heck of a difference, right? As you've seen here, maybe if I had 8 decimal places, I might see a difference at the 7th decimal place, but numerically, it's not going to make a heck of a difference. I think it might make a noticeable difference if there was only 5 women and 4 men. Can you imagine when there's very few people? I think you might see a difference then, but in general, no. And that is the end of that question. Any questions at this point? Is that a good, I don't have questions, or a bad, I don't have questions? It's a thumbs up one, I like. Okay, we're going to continue with the next question, but I want to...
How about a neutral?
Neutral will do too, Robert. I can live with neutral. So what we're going to do is continue with this in a few minutes, but before then, it's been brought to my attention because of an email that was sent to me by a student who asked a question that, if they had been in class, was pretty much, they'd have to have known it. It wasn't to do with stuff, it was to do with other things. And it came to my notice then, because they were marked as present, that all they did was turn up, put their name in, and then go away. No, yeah. So we are changing our attendance policy, because I don't think someone who puts their name and then goes away deserves to be given attendance or participation, because they're not. Now, I can tell Christy is here and Robert's here and Lauren's here. I can see you a lot, but some of you don't have your video on. So what we're going to do is, right now, from 12:36 to 12:37, you are going to say your last name and do attendance. So even if you did it already, start from scratch and put in your last name, right? And you've got from now to 12:37 to do it. So if your name is not in that time window, you're not here. That seems fair, doesn't it? If you're not here right now, you shouldn't get attendance. So go for it. Okay, has everybody who said hi said hi? Cool.
So now we can leave, right?
Well, I can see 14 chats.
Do you want us to say our name as well?
No,
Okay.
I don't need you to say hi. Just say, you know, your last name, usual attendance thing. That's all I need. I'm doing a quick head count. 5, 10, 15, 16, 17, I'm 18, 14. 4 of you are not here. Interesting. Obviously you are, because I'm talking to you, right? But 4 of you are not here. So they don't get attendance for today. That's fair, isn't it? You lot turn up. I don't see why someone should get attendance for just putting their name and leaving. It's not really right. Okay, back to our questions now. I've forgotten where we are. Are we still looking at the homework screen? Yeah, let's have a look at that then. So, data on testosterone levels of men in different professions were given in a paper. The researchers suggested that there are occupational differences in mean testosterone levels. Medical doctors and university professors were 2 of the occupation groups that they tested, and they collected the mean and standard deviation of each of these, and they did some other stuff like dot plots and who knows what else. And a computer output, which is what all of this is, gives you all that information kind of in a very precise form. So I am going to make this bigger. There. I wouldn't worry too much about that salt bun, because honestly, you don't need it for this piece. If I asked you for the mean level for doctors, it's 11.5 units, and for professors, it's 10.5. And the standard deviation is 3.37, and the standard deviation is 2.5. Do you see this stuff here? These 2. You don't use them, you don't need them. Pretend they're not there. Right. Now, which of these formulas do you do to calculate the thing. Which one of these 5 guys is the formula? Right, I see a finger on 3. Do you agree? Third one. Remember when we did it by hand, it was that guy? Right. Now, what is the statistic? What is the standard error? And what is the multiplier, right? That's where we are now. Now, if we go to the statistic, they mean by the statistic the difference between the two. So it's that number. So copy. 1. So there's a difference of 1 between the doctors and professors. Check. The standard error. The standard error is not here, but I guess I should get it by using salt. So I guess that salt button is necessary. So I'm going to go over here and I'm going to retype the information. So it's going to be 11.5. And the standard deviation is for the doctors is 3.37. And the sample size for doctors was 16. And then if we do the second group, which are professors, it was 10.5. And if you go here, it's 2.57. And over here, it's tiny sample size of 10. And we want a 95% confidence interval, generate results. I'm going to have to shrink it a little bit so you can see the numbers. Here we go, a little bit more. There is the standard error. So standard error goes here. And 2 decimal places, so I guess that's 70. Are we comfortable with those 2 guys? Right, now, I'm going to leave that to the end of this question, so I'm going to kind of skip it for a minute, and then interpret the confidence intervals. What assumptions can you make? And this one. So let's start with, make this a nice big picture. Yeah, that's good. Interpret the confidence interval. So the confidence interval here is -1.43 to 3.43. Hopefully that's the same numbers we got. Yeah, can you see that's roughly -1.43 and 3.43? We seem to be disagreeing with that. I guess that's just rounding off issues. So interpret the confidence interval for different, be specific, right? So we are doing that 95% confidence interval. So there's a 0.95 probability that the difference in population mean to testosterone levels of medical doctors and unit is contained within that interval. I don't need to look anymore. And that's a 0.95%, isn't it? It's the same thing as 95%. What assumptions are you making? It's, well, because we may have more, we are assuming only that neither sample showed outliers. No. We are assuming that only the samples, that the samples are representative. Would you agree you make that assumption? That the people you asked were similar to the others? On the basis of this interval, right, let's go back to that interval. Can we say that there's any real difference between the doctors and the professors? Isn't that one of those negatives and positives? Now there's one guy left out here. Let's return to him, the multiplier, right? You remember that magic T-star thing here? Right. I'm going to have to hit the salt button. And when you go for the multiplier, you go here, right? And you click on T distribution. And the degrees of freedom, right, if you add the two numbers together, isn't there 26? What was my formula for degrees of freedom? N1 plus N2, how much do you take away? One. Some textbooks two. Some textbooks are the difference of them. So there are going to be some differences here, depending on how this book does it. So 26 take away 1 is 25. And I want a 95%. And I shouldn't have done that yet. Which one of these dots do you use to get the multiply?
Between.
And then I put in 95. And the number that I got is this guy here. Now, that might not be exactly what they wanted, because isn't there different ways to count degrees of freedom, right? But it won't be miles away from it. 2 decimal places, so that's a 6. If they decide to take away 2, then the answer's 24. And the number changes to 2.06, which means it doesn't change at all, right? So that won't make any difference. If you decide to use the smaller of the 2 sample sizes, which I've seen that done, it would be 10. And if you did 10, okay, the number does become quite significant. So it'd be about 2.22. So you're going to have to try take away 1, take away 2, or take away 1 from the smallest number and see what you get. And one of those guys is going to get you the right answer. But once you've figured out which one it is, that's the one you should use for any other question where that happens, because at least they're going to be consistent. My gut feeling is, and it's totally just a gut feeling, is that they're probably going to just add them together and take away 1, or add them together and take away 2. But I've been proved wrong before.
The question states the degrees of freedom are 22. If you scroll down.
22?
Yeah, it says DF equals 22.
Oh God, I'm totally wrong. Which I guessed I was. Well, that means I don't need to worry about what degrees of freedom, because they're going to tell you. That makes life a lot easier. I've got a feeling that we've actually done question 7. Is that not where we left off last time, or was that my other class? Have you seen question 7 before? Okay, so that was my last class. That's fine. Let me get this thing set up again. Try the 2-window deal. Is this 2-window thing working okay, or is the writing very small? Okay, okay, for some of you. Give me a few seconds to get my windows. Come on, stop fighting me. You're just going to fight me, aren't you? I need to scroll to the right, and it's not letting me scroll to the right. Okay, give me a few seconds to close as many windows as I can get my hands on. Darn it in space. I have 2 screens, and it's jumping between screen A and screen B. Finally. I had it. I had it. I tell you, I had it. Lost it again. Okay, compromise. Do that. Yeah, that'll work. Go away. Well, thanks for your patience hanging in there where I do my thing. Here we go. So, right, so this one is about students and their non-dominant hand. So most people are right-handed, so your non-dominant hand would be your left. And each of 63 students in a stats class use their dominant hand to write down as many many letters of the alphabet in order that they could in 15 seconds. And we ended up with basically males and females, and the average number that they managed to do and the standard deviation. And just like the other one that looked like this, won't these numbers, the SE means at the end, be ignored, right? They're not going to get used in this story. So what's the mean number of letters printed by females? And the answer is they got on average about 12 and a half letters.
You're not sharing your screen, Professor.
Okay, thank you. Okay, how am I going to do it? There we go. Right, we sure now? Right, so there's the story we talked about, non-dominant hands. Here is the table with all the information. The mean number by females was that 12.586. The mean number of males, they managed to do allegedly that one. You want the answer to what kind of accuracy? Did they mention any accuracy? Nope, so I'll just put all the decimals in. What's the difference between the two? Oh, there we go. It's females, take away males. So the difference is that number. What is a 95% confidence interval? It's from this number all the way to that number. In a lot of ways, isn't it just knowing where to look? Although a lot of them are pretty obvious. The thing to the left tells you what they are. Can that just be our standard? I'm 95% sure the true differences between these two, and figure out which version of that story says the same thing. Now, if you draw a picture, negative 3.3 to 1.02, one of these pictures should be the same thing. So I want a negative 3 and a bit and just over 1. And I believe it's that picture. Would you agree that's negative 3 and a bit and round about 1? Now, based on this picture and on this fella here, is there enough evidence to show that there's a difference between males and females? Agree? It's Chrissy shaking her head. Isn't that another no? How do you know that there's not enough evidence here to show a difference? Contains 0. That's what Rob was saying. Make sense? Right. Now, if all of the numbers were positive, I know they're not, but if all of those numbers were positive, wouldn't that mean that females actually could do more letters than men? And if they were all negative, wouldn't that be females do less than men? But when you get a 1 of each, doesn't that mean there's not enough evidence to tell the difference? And then what you have to do is read through these 4 sentences to figure out which one of them means the same thing as what we just said. And they almost always contain that interval, contains 0, that kind of thing, right? It says find the value of the unpooled standard error. Well, the standard error, I'm sketching, is not here. Can I skip this bit? Because time up. Wouldn't we just go in here and put all the data, and then when we said generate result, what's the wrong one? What the heck are we doing? If we were doing generate results, wouldn't we be able to get an answer over here? Standard error. We did it in one of the earlier questions, but I just realized that we are finished for today. any of these later questions that I haven't had time to cover, like question 6, even if they don't mention salt, couldn't you still click in a salt somewhere else and put the data in? It's not like you need to always have a salt button. If you can let salt do it for you, I would suggest that you do that. It just makes life easier. Okay, well, that's bye-bye. Have a nice weekend, everyone. I'll hang about for some questions. Otherwise, I will see you Monday. You too, Ariel.